All right, well, we've now come to the end of our basic understanding of designing an experiment. So this chapter is all about designing the experiment. We talked about ways of collecting data and formulating the questions that are appropriate for the age or the maturity level of those that you are working with. Then we've also talked about ways to organize the data, whether we're using histograms, line graphs, dot plots, okay, stem and leaf, all of those. And now we're going to take a look at analyzing or interpreting the data. Okay, so we are taking a look at interpreting. So there's a couple of ways we're going to do that. It basically comes down to twofold. Okay, we're going to take a look at analyzing our data points. Okay, so we're going to look at two different branches today. We're going to take a look at the measures of central tendency, which you may already be very familiar with, measures of central tendency. And ways to look at the variance or the spread. So the measures of central tendency are what you might be familiar of mean, median, and mode. Okay, and we're going to talk about how to do those. And then we also need to take a look at the variance or our spread. So instead of measuring things that are in the middle of our data, now we're going to be spreading our data out and seeing what that represents. So we'll be talking about words like range. We're going to be looking at quartile range or inner quartiles. So we're going to talk about what a quartile is. And then we're going to be taking a look at what's called standard deviation. So you may also, if you've had some statistics, you may have seen normal distribution. So again, I have typed up the examples for you. I will pause the video and write some of them down, but it might be easier for you to print that out and you can take the notes right on those sheets, or at least have them to reference. Okay? So let's start off with measures of central tendency. We're going to look at mean, median, and mode. Before we do, we need to take a look at what we mean by rank. Rank or ranking data. When we rank something, we put them in order. Now that order can be from least to greatest or greatest to least, but just put them in order. So this is ordering your data. Either least to greatest or greatest to least. Okay? And then what we'll take a look at is we'll look at definition of mean. Now you may already be familiar with this because the mean is the same as taking the arithmetic average. So how do we take an average? Well, we add up all the data points and divide by the number of data points. So the symbol for mean is an X with a bar over it. Okay? And that's the same as taking your first data point, x of 1, adding it to x of 2, adding it to x of 3, and you keep going until you've added it to the very, very last term. I'm going to call that x of n, where n represents how many of them that we are adding up, and then we divide it by the number of terms we have, or n. So the mean is just like finding the average. Then the definition of mode is the data point which occurs most often. I forgot about median, I'll come back to that. The data point or points occurring most often. And you can have more than one mode. It could be bimodal or trimodal. So if you have several data points that are the same number, and whichever one has the most is called the mode. Whichever two have the most are called the mode, as long as those numbers are the same amount. Okay? And I forgot to put median. So the median is the middle term. The median is like median on the highway is the middle of the highway. So the median is the exact middle value after you've ranked it. The exact middle value of the data points after ranking. Now we're going to take a look at if there's an odd number of data points or an even number of data points. It's got to be the exact middle one. Sometimes you might have to average the two middle terms to find it, but that's what we're going to look at. So let's first take a look at example number 1 that I gave you. So I'm going to go ahead and we're going to practice our central tendency, mean, median, mode. Okay. Go over here. So while you're looking at that first example, this one I can write down with you live because it's not too much. What we've got for example number 1 is we want to find the mean, median, and mode for the data set representing men's height. Mean, median, and mode of the data set. So here are men's heights, which were measured in inches. So I'm going to give them to you the same way they are in the example. 65 inches, 68 inches, 71, 72, 72, 72, 72, 73, 74, 74, and 77. And when I typed up this example, I went ahead and ranked it already just to save a little time. So remember, ranking means put it in order. Okay, now let's go through each one of these. If we want to find the mean, okay, the mean is, we need the sum of all these data points, 65, 68, 71, 72, 72, 72, 72, and then we want to divide by the number of data points that we have. 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10, 11. 2, 4, 6, 8, 10, 11. I wanted to make sure I had the right number. Well, grab your calculator. You're totally going to need your calculator. And if we do that sum and we divide by 11, we should get that the mean is 71.82. And if you're within about 1/10 or so, I'm fine with that. Okay? So add them all up, divide by how many there are. That's how we find the mean. Now the median, remember, is the exact middle value. And before I do the median, because I'm going to have to erase this, let's look at the mode. The mode says the data point or points occurring most often. Well, if I look at these heights, there's one that occurs more often than all the others. It looks like 72 occurs the most. So in this case, our mode would be 72. Okay? Now, if two of those weren't there, and I had two 72s and two 74s, we would say it's bimodal, and we would list both of those numbers. If it was the case that there were no repeat data points, then we would say there is no mode. Don't leave it blank, but if there is no mode, just state there is no value that repeats. And now let's take a look at the median. Now the median is the exact middle number. So what I'm going to do is I'm going to write these out again. I've got to rank them first. And again, I gave them to you in ranked order. 65, 68, 71, 72. Hopefully I'm not going to go off the edge. Oh, barely made it. Now I should have 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median is the exact middle. So if I start and I just go, well, there's an odd number. So these two pair up, these two pair up, these two pair up, these two pair up, these two pair up. It looks like this particular number 72 is the exact middle value. Another way to think of it is there's 11 terms. 11 divided by 2 is 5 with 1 left over. So if I come in from either direction 5, it's the 1 left over that would be the exact middle. So in this case, our median is 72. So we first have to go over these central tendencies so that when we now start looking at the spread, depending on which method we're looking at, will depend on whether we are focusing on the mean or the median. I'll say that again. Once we start looking at the spread or the variance, okay, if we're talking about standard deviation, we worry about starting from the mean. But if we're looking at a quartile and we're looking at a box and whisker plot, then we need to focus on the median. So we need to make sure we can calculate both of these before moving on to spreading the data. All right. Now I did put a second example. I did put a second example on the mean, median, and mode. So you may want to try it and then we can discuss it in class if you want me to go over it with you. Okay. So now that we've talked about the measures of central tendency, that's the mean, median, mode. Now let's look at all the variance, the spread. So I'm going to show you several ways to interpret all of these data points through pictures, because pictures can help in so many ways with what the overall data set looks like. So how do teachers use these? Well, oftentimes we do this with test scores or reading scores or just an assessment so we can see with a picture how well our students are doing. Okay, so let's take a look at the variance now. Or think of it, whoops, board's still wet. Get it. Measures, that's really damp. Both of them are. Measures of spread, okay? Measures of dispersion. Okay, so first we'll look at a couple of definitions and I'll include a picture with one of them. The first definition is what we mean by range. The range of data, the range of numbers, how far the numbers differ from each other. So remember, we've ranked them. So we need the difference between the greatest and the least value gives us our range. Okay, so the range, what's the highest score, what's the lowest score, and figure out how much they differ by, how much is between them, okay? Between the greatest and least value, I should say, of the data set. Never finished the sentence. And then I'm going to give you the definition of a quartile, and then we're going to look at what it looks like, and then we'll practice. A quartile, well, quartile, here I'll write the word first. Look at sort of that base part of it, quart, okay? Quart means we're talking about 4. We're dividing into quarters or fourths. So it's a type of measurement which divides a data set into 4 parts. They don't have to be equal, but they're just 4 parts, and these use the medians. So it's a type of measurement which divides, and I'm going to add something in here, divides a ranked, because you want to put them in order first, data set. Remember, it's quartile, so it's got to have 4, into 4 regions. They're not necessarily the same number in each region, okay? They're not necessarily equal. I'll show you with a diagram here in just a minute, okay? But we're using medians. There's not a whole lot of room down here. Let me see what I've got actually. No, because I want to make sure I write it out so you can see it. I'm going to put down 9 data points. Okay, so for example, let's just rank 9 data points. Now I'm not going to do numbers yet. We'll do that in a moment. We just want to look at the overall concept. So let's put 9 data points down. X sub 1 for our first data point, X sub 2, 3, 4, 5. And I chose an odd number on purpose for this first, just for the visual, because we're talking about medians, the exact middle value. Okay, now we're dividing these into 4 parts. Remember, they do not have to be equal parts, but they might be, but they might not be. So the very first thing we're going to do is we need to divide it into 4 parts by finding the median. So I need the exact middle value. Well, since there's 9 data points, 9 divided by 2 is 4, and there's 1 left over. So because this is odd, there will be an exact middle value. So if I come in 1, 2, 3, 4, you'll notice that we have our exact middle value. So this number exactly in the middle, that's our median. And I'm going to come back and write something underneath that. Now I'm going to do the exact same procedure again. In the first half of the data set, in this first half, okay, I've already know where the median is, so I'm going to just cover that up. In the first half of the data set, I want to know the exact middle value of these 4 points. Well, since 4 is an even number, I have to divide this exactly in half. Well, if I divide this exactly in half, you're going to end up with a value that's right between these two. Okay? Then I'm going to do the same thing with the other half of the information. We have the median. Now I'm going to take this upper half and figure out where the exact middle value will be. Again, there's 4 of them. So I'm going to have to go exactly between the 7th and the 8th one. Okay? And so what we end up having is we end up taking a look at, we have 4 regions. We have this first region, this second one between that and the median, between the median and this third line, and then to the right. So we go in order. This first part is called quartile 1. So I'm going to call that 1. This is actually, I'm going to write it out because it's the first time we've seen it. This first part would be our lower quartile. Then we have our median, which is our second quartile. Here's 1 quartile, here's 2 quartiles. This third one, this third line would be our third quartile, and it's called the upper quartile. And so those 3 lines have divided this into 4 parts. And then we have our lowest value and our highest value. Remember, our lowest and our highest came up with our range. So this very, very, very lowest one, this very first term, we call our lower extreme. And this very, very, very last term, I think I'm still on screen, is called the upper extreme. So all our data sets are kind of focused with these 5 things that we need to focus on. Our lowest number, our first quartile, second quartile, which is the exact middle value, third quartile, and our upper extreme. Okay. All right, now once you have that down, we have something, and it's a very important idea, and it is called the interquartile range. Sometimes you see it as the IQR. Interquartile range. We already talked about range. Range is the difference between the highest and the lowest value. Well, if it's on the interquartiles, and these are our quartiles, take a look at your upper quartile and your lower quartile. The range between them is what we call the interquartile range. Okay, so here's your interquartile range. It's the difference between your quartile 3, your upper quartile, and your lower quartile. That's the range. Okay, so what's really nice about that interquartile range is it's never influenced by your highest and lowest points. It's only talking about the majority of the data points that are in here. All right, so what I'd like to do is practice 1. And in those examples, I gave you 2 of them to practice. So again, we can do 1 of them together. And then we can, if you want a second one to practice, we can go over it in class. That's perfect. All right, so let's look at example 3 on this data set. And if you do not have the examples printed out, I'm going to pause the video and I'm going to kind of simplify the data set. All right, so here we have the example where we are given the ages of United States senators when they assumed office. Okay, And what we want to do is we want to figure out and we want to develop a quartile. We're going to start doing a box and whisker, but we're not there yet. We just want to find the median, our lower quartile. So we want to figure out our middle point. Then we want to figure out the median of the lower half. We want to figure out the median of the upper half so that we can determine our interquartile range. All right? So I'm going to sort of leave this up here so that we can sort of mimic this. The very first thing we need to do is we need to rank our data from low to high. All right, so if we rank our data from low to high and we just start listing them, well, we have a 42-year-old, we have a 42-year-old, we have a 45-year-old. Then what have we got? A couple of 47s. I saw 50 a few times. 50, 50, 50, 3 50s. I think I may run out of room. I may have to erase this and start. I'm going to move these over. So while you keep putting those in order, I'm just going to move my data over so I don't run out of room. I just didn't plan well. So I'm going to start over here so I have a little bit more room. So where did we leave off? We had a 42, 45, 47, 47, 3 50-year-olds. I think that's where we left off. 52, 53, 54. Then what do we got? 58, 58. So it's not difficult, it's just a little tedious. It takes a little bit of time. We have a 60, a 60, and a 61. I think I got it all. Okay. 1, 2, 3, 4, 5, 6, 13, 14, 15, 16. All right, so I have 16 of them. 1, 2, 11, 12, 13, 14, 15, 16. Okay, looks like I've got them all. Now, we want to create all of this. So we want to find the median. All right, well, first of all, the median is the exact middle value. Since we have 16, 16 divided by 2 is 8 with no remainder. So that means I need to come in 8 on each side. Well, when I do, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you'll notice there's no number that's exactly halfway between them. So I average them. If I average 50 plus 52 divided by 2, will give me this exact middle value, which you may have already seen because you went halfway between 50 and 52. So you got 51 as the median. Then what I'm going to do is I'm going to do the same thing to both halves of data. So the lower half, everything less than this, I need to find the exact middle value. 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4. So 1, 2, 3, 4. 1, 2, 3, 4. Again, I have to split. And what's exactly between 47 and 47? Well, 47. Okay, so this lower quartile, this Q1 is 47. This median is always in the middle. It's our middle quartile. And then we do the same thing on the other end. Well, again, we already know there's going to be 8 of them. Half of 8 is 4. So it looks like I'm splitting 58 and 58. So this upper quartile, okay, will be, oh, I forgot to write that one down, will be 58. All right, sorry, I got them a little out of order. Okay, so I'll make this one look the same. Okay, so we've now found our median. We have found the lower quartile. We have found the upper quartile. Now the only other piece of information to find is the interquartile range. The interquartile range is the difference between, the span between, okay, the variance between the upper and the lower quartile. So the upper quartile is 58. The lower quartile is 47. So that interquartile range, it appears that they are 11 away from each other. Okay, so that IQR is 11. So that's how we find that interquartile range. So I have a second example there for you. If you'd like to try it on your own, and again, I can give you the answers. We can check, we can do them in class to see how that goes. Okay. So now we've taken a look at how to find these. Let's take a look at why we find them. So we're going to use all of these quartile ranges to create what's called a box plot, or you may have heard it as a box and whiskers plot. Okay. All right, so let's take a look at a box plot. And again, a box plot is a way to visually see where or how your scores or your assessments or how your data points look overall. So you can sort of get a visual. All right, so let's take a look at what's meant by a box plot. You may have also heard this as a box and whiskers plot. Okay, so this is a nice way to visually see the data. And when you do this, you need 5 summary points of the data. Using 5 summary points. Those are the ones we just went over. We're going to use the lower extreme, then we're going to use quartile 1, quartile 2, quartile 3, and the upper extreme. So that's why we needed to practice what we just did a minute ago, right? And then we're going to create a box and whiskers sort of setup. So if we look at the examples, we're going to take a look at example 5 and example 6. So we'll do example 5. I'm going to pause again so that we can write down the example in case you did not print it out. So I'll be right back. Okay. So here we are with the number of Academy Awards that each movie won. And Slumdog Millionaire, Braveheart, Schindler's List, Marty. So there's a whole variety of them here. What we want to do is we want to create a visual to see the box and whiskers. So what we're going to do is we're going to do the same 5 categories that we did a little while ago. So the first thing we need to do is we need to rank our data. Okay. So in ranked order, I have a 2, a 2. So I'm going to go here. I have a 2, a 2. Got that one, a 4. 1, 2, 3, 4 5s, 2 7s, and an 8. Okay. Make sure I've got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I should have all 10. All right, now let's do exactly the same thing we did before. Okay, and let's create a box and whiskers plot. So here it is. First thing we need to do is we need to find our median. Since we have 10 scores, we have 10 numbers. If I divide 10 by 2, I get 5. So I should have 5 on each side. I do. So right here is the exact middle value. So here's your median, okay? So here we have our median of 5. Now, from there, we need to also, and I'm going to do it with the numbers first, and then we'll do one with the number line, okay? So I'm going to do it with the numbers first, and then I'm going to show you the better way of doing it with the number line, but right now it's the visual. Now, if I look at the lower half, since there's 5 numbers down here, the exact middle value is the number 4. So right here, we have our exact middle value, and I'm just going to do this for a moment. So here's our first quartile. Here's our second quartile. We need to split the upper half. 1, 2, 3, 4, 5. So we have, and again, I'm just doing this visually, and then we'll do it again with our third quartile. And what we're going to do is we're going to create a box out of this. So what do I mean by that? Well, I literally mean we're going to take these numbers, and right now I'm doing a visual. Second example, we will make it look the way we will always make them look. So we've put a box around the range that goes for the middle part of the data. Remember, this is 4 parts. So the middle part is all between the first and the third quartile. And then we have our lower extreme. So our lower extreme is the number 2. And our upper extreme is the number 8. So visually, what we have is we have a box, and then we have these whiskers. And again, I'm going to show you the better way of doing this. These whiskers go all the way out here. I did not mean to go through the middle of my box here. That was just an oversight of me getting too rambunctious. That should not be there. I apologize. So what did I have? I had a 4. I had a 2, a 2, a 4. One, 2, 3, 4 of them. Is that right? 2, 2, 4, 5, 5, 5, 5. Okay. Now, so what I end up having is I have my box and I have my whiskers. Okay? Now, as you can see, this is kind of messy because it goes right through the middle. So there's actually a better way to do this. So we're going to do this again with a number line. Instead of doing a second example, I'll just use the same data. And then, of course, if we want our inner quartile range, we need to know how wide the box is. So this interquartile range would be third quartile minus the first quartile. So in this case, this would be our number 7 minus 4. So it looks like the majority of that data is going to be within 3 scores of each other. And again, this gets kind of messy if you do it this way because you've crossed out numbers. So I'm going to graph the same thing on more of a number line scale. Okay, so let's do this again. Do this again. I'm going to keep the data the same instead of starting a whole new example. But I did give you a second example in those notes if you want to try it. All right, so if I look at my information. If I look at my data points, I can see that the lowest data point is 2 and the highest number of Academy Awards was 8. So another way to do this is to have a number line. And I'm going to go, all right, I'm just going to start here at 0, and I'm going to go to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I wanted to go past my lower and upper extremes just for making it look a little nicer. Okay, and again, we can rank our data. Again, we can find all of our extremes. So if you rank all your data like we did before, and we say, okay, we had a 2, a 2, a 4. You already have this written down. 4 5s, pair of 7s, and an 8. We have all 10 of them. So the very first thing we would do is we'd say, okay, let's find our middle number. Let's find our median. So we said our median was 1, 2, 3, 4, 5, right between the 5s. So then what I'm going to do is, it looks like our absolute median is 5. We'll switch colors here. So the absolute middle of our data is right here at the number 5. That's our second quartile. Then we're going to go and we're going to find, remember, half of the first one. So 1, 2, 3, 4, 5. I've got to go halfway down between that. And if I take a look at, I'm looking at my lowest data point is 2. So my lowest extreme is 2. And what is exactly halfway between 2 and 5? 1, 2, 3. Okay. If I take a look at this exact way between, I've got 1, 2, 3, 4, 5. So if I look at my median would be the number 4. So that's where my lower quartile is. If I look at my other data points and I find the median, the middle value here is the number 7. So that's where my upper quartile is. So now I create the box. Remember the box? For box and whiskers, all of this comes off of the median values. And then my upper value is the number 8. My upper extreme goes to 8. And so now I'm going to make the whiskers. The lowest value is 2, the upper value is 8. Oops, I went right past 8, didn't I? And so here are the whiskers, and there's the box. And now you can visually see that the majority of the scores are between 4 and 7. And so, same idea. Interquartile range would be 7 minus 4, which is 3. So that's the better way to represent it, using a number line and drawing kind of above it instead of going through the middle of it. But I wanted to show you first where all the numbers laid in, or all the numbers were inside that box. Okay? And now, we touched the other day on outliers and what they look like. We're now going to actually take a look at how to calculate an outlier, because there's an actual formula for an outlier. An outlier, when you're glancing at a data set, that outlier is that point or points that are well away from the cluster of values or data points. Well, there's an actual way to calculate whether or not something is an outlier. Because just because it appears to be an outlier doesn't mean it actually is an outlier. So the definition of an outlier. It's a data point which is widely separated from the rest of the group. Okay, and we do have a formula. The way to figure it out is it's a value that is more than 1.5 times the interquartile range, above the upper quartile or below the lower quartile. So I'm going to write that down. It's a value which is greater than or more than 1.5 times the interquartile range. Below the first quartile or the lower quartile, or above the upper quartile. So just because it looks like an outlier doesn't necessarily mean it is an outlier. All right? So let's take a look at example number 7 that I gave you. And again, I'm going to write these down. All right, so the example that I have, example number 7 in that printout, says the following data set represents 10 student scores on a square root quiz. Unfortunately, one of the students had a fight with his girlfriend at lunch and could not concentrate, and he gets a 35. So here are the scores. I went ahead and ranked them for you just to save a little time. Determine whether there are any outliers. And when you make a box plot, they would be denoted as an asterisk. All right, so the first thing we need to do is we know that we need 1.5 times the interquartile range. All right, so the first thing we need to do is find the median. Okay, well, if we look at the median, we know there's 10 scores, so half of 10 is 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the median is exactly between 67 and 69, which is 68. And remember, that's our second quartile. So our second quartile is 68. Then we need to take and find the median of each half. Well, since there's 5 scores, the exact middle value here would be 61. Okay, so let's find quartile 1, which we just found to be the number 61. We need to do the same thing on the other half to find that upper quartile, that third quartile. So if I do that again, 1, 2, 3, 4, 5, the exact median would be 71. And we know the interquartile range is how far it is between quartile 1 and quartile 3. Interquartile range, 71 minus 61, which is 10. So this interquartile range is 10. Now by definition, a value is an outlier if it is 1.5 times larger than that. And then you add it to the upper quartile and you subtract it from the lower quartile. So let's figure that out. An outlier is going to occur, okay? If we're going to have outliers, we would take the upper quartile and add 1.5 times the interquartile range. Or take the lower quartile and subtract 1.5 times the interquartile range. So the third quartile is 71 plus 1.5 times 10, 71 plus 15. So an outlier would occur anywhere greater than that number. An outlier is also going to occur if I take that first quartile, which was 61, and we subtract 1.5 times 10. 61 minus 15 gives us 46. So anything that is less than 46 is also an outlier. So do we have any? Well, if we look at our data set, if we have anything greater than 86, we do. 88. So 88 is an outlier. Similarly, anything less than 46, well, we do. We have 35. Therefore, 35 is also an outlier. So they might appear to be outliers, but until you actually do the calculation, you won't know whether or not they're outliers. All right? And then the last thing we want to take a look at, I know it's getting kind of late. Last thing we want to look at is how to look at standard deviation and a normal curve. Okay? I think what I'm going to do is I'm going to do a separate little video that has to do with standard deviation and the normal curve. It's still part of 10.4. And then also talk to you a little bit about what is called the mean absolute deviation. So I'm going to stop here. Then I'm going to do a separate video continuing with 10.4 with standard deviation, the normal curve, and what those look like. All right, so until next time.